Imagine one morning scientists point their telescopes to our deep space and suddenly realize something is wrong. A black hole has been found that simply should not exist, not according to physics, and not according to any model, and not according to what we thought we knew about the universe. This is not a science fiction, this is a real life discovery that is making NASA, ESA, and astrophysicists around the world rethink the law of cosmos. Today we are going to explore the black hole that has shattered scientific expectations, why experts are calling it impossible, and how this discovery might rewrite our understanding of how a star lived and died. So sit back, because this is one of the most fascinating mysteries in modern astronomy. Part 1. What makes this black hole impossible? In recent years, astronomers had found supermassive black holes, intermediate black holes, and stellar mass black holes. These are normal until now. The problem began when scientists using LIGO, Laser Interferometer Gravitational Wave Observatory, and Virgo detected gravitational waves from a collision between two black holes. One of them was 85 times the mass of our Sun. But here is the twist. According to stellar physics, a black hole between 60 and 120 solar masses cannot exist. This range is called the pair instability mass gap. Why? Because stars that big should explode completely in a pair instability supernova, leaving no black hole behind. So how did an impossible 85 solar mass black hole form? This single detection shocked astrophysics. Part 2. A quick story. The star that refused to die. To understand the mystery, imagine a star much bigger than our Sun, a hot, bright blue giant burning millions of times more energy than Earth receives in a year. Stars like these usually end their life cycle as supernovae, collapsing into neutron stars or small black holes, or they explode violently, destroying themselves completely. But the star behind this black hole did not follow the rule book. Instead of dying peacefully or exploding into nothingness, it left behind a massive black hole that was never supposed to fall. This is like finding dinosaur bones in your modern kitchen. Shocking, confusing, and rewriting the timeline. Now part 3. How do we know it's real? The power of gravitational waves. On May 21, 2019, the LIGO Virgo collaboration detected a set of ripples in space-time gravitational waves traveling across the universe for billions of years before reaching Earth. These waves came from a merger between a 66 solar mass black hole and the mysterious 85 solar mass black hole. The collision created a final monster, a 142 solar mass black hole, the first clear proof of an intermediate mass black hole. This discovery was published in journals and confirmed independently. It was not a glitch, not a mistake. It was real physics happening 7 billion years ago. And the numbers were not just surprising, they were impossible. Now part 4. Why scientists are calling this the black hole that should not exist? Astrophysicists have spent decades modeling how massive stars evolve. According to the models, stars between 8 and 40 solar masses become small black holes. A star between 40 and 60 solar masses tends to become neutron stars or explode. Stars between 40 and 60 solar masses become neutron stars or explode. Stars bigger than 120 solar masses collapse directly into black holes. But the range 60 to 120 is a forbidden zone. So discovering an 85 solar mass black holes means the star that made it should have exploded. No black hole should have formed. Our models are incomplete or wrong. This is why scientists worldwide started asking, are we missing something about how stars die? Could black holes merge multiple times to grow bigger? Is there new physics we have not discovered? This one object forced a complete revolution of stellar evolution. Part 5. NASA and ESA theories. How did it form? Here are the leading explanations scientists are studying. Number 1. Repeated black hole mergers. Hierarchical merging theory. Inside dense star clusters, black holes can collide repeatedly, forming bigger and bigger ones. Think of this like a cosmic snowball effect. Small black holes merge. The resulting black hole merges again and again until it reaches forbidden sizes. NASA simulations show this is possible, especially in globular clusters. Number 2. Primordial black holes, PBHs. Some experts believe this black hole might be a primordial black hole formed right after the Big Bang, not from a star. If true, this discovery could explain dark matter, rewrite cosmology, solve multiple physics mysteries. But this theory is still under study. Third, extremely low metal stars. Stars in the early universe had very few heavy elements or metal. Such stars behave differently and may collapse into bigger black holes. This supports the idea that the black hole was formed billions of years ago in a very young universe. Now part number 6. What this means for the future of space science. This discovery is not just an astronomy headline, it's a turning point. Here is how it impacts our understanding. Number 1. Stellar evolution models need updating. The life and death of massive stars must be redefined and in textbooks. Number 2. Intermediate black holes are real. Until recently, we only know about stellar black hole and supermassive black holes. Now we have proof of the missing middle. Third one, the universe is more violent than we thought. Massive mergers happening billions of years ago means the cosmos was full of chaotic energy. Fourth, new instruments will reveal more. With upcoming telescopes like James Webb Space Telescope and LISA Laser Interferometer Space Antenna and extremely large telescope ELT, we may detect dozens more impossible black holes. Part 7. Why does this matter for us today? Here is the real reason this discovery matters. Because every time physics breaks, we get closer to understanding the true nature of the universe. Just like Einstein revolutionized gravity, Hubble discovered universe expansion, Hawking changed our understanding of black holes. This discovery might lead to new physics, new theory, new breakthroughs in space technology, and better understanding of dark matter and dark energy. Every possible discovery pushes science into the next era. So in conclusion, the mystery has just begun. We found a black hole that should not exist, a star that refused to die, a discovery that broke the rule of physics, and this is only the beginning. As telescopes improve and gravitational wave detectors become more powerful, we may soon discover even stranger objects, black holes, bigger, older, or stranger than anything we have ever imagined. The universe is speaking, and for the first time, we are finally able to listen.